In this lesson, we will be graphing quadratic functions. We will be graphing first the parent function of the quadratic, and then we will be graphing the quadratic in vertex form and in standard form. A couple of things to remember. First, the graph of a quadratic equation is a parabola. The vertex is the highest or lowest point of the parabola. The axis of symmetry, or sometimes called the line of symmetry, is the vertical line that divides the parabola in half. Remember that the parabola is symmetric. The leading coefficient is going to determine a couple of things. First, how wide the parabola is, and second, the direction of the parabola, whether it opens up or down. Let's take a look at our first example, which is the parent function. The first thing we want to determine with our parent function is what the vertex is. In this case, if we start plugging in values to a table, we can find out some points for our parabola and find out the vertex. So let's start plugging in some points. Let's plug in 0, 1, and 2. So if we plug 0 into our equation, 0 squared is 0. If we put 1 into our equation, 1 squared is 1. And if we plug 2 into our equation, 2 squared is 4. So if I graph those 3 points at 0, 0, 1, 1, and 2, 4, it looks like I have the right side of my parabola. But to check to be sure, I'm going to plug in a -1 to make sure that that is the point of reflection on the other side of our parabola. So plugging in a -1, if I have -1 and I square it, that's going to be a +1. So 0, 0 is the vertex of my parent function. I know by the leading coefficient, which is a +1, that my parabola opens up. Since my parabola opens up, my vertex is going to be my lowest point of my parabola. Since it is the lowest point, the vertex is a minimum. The axis of symmetry is the vertical line that divides my parabola in half, right down the middle. The axis of symmetry is written as a vertical line, and a vertical line is written as x equals, and then the value at that line of the x coordinate, and at this point x would be 0. Let's finish putting in some of these points of reflection, and we could continue from there. We could also put in the point 3. 3 squared would be 9. So I would be at 3, 9, and I would reflect that to the other side, which is at -3, 9. And then let's draw in our parabola. This is the graph of the parent function. From there, all other quadratic functions are built. Vertex could be shifted either right or left, up or down. Also, the parabola could be wider or narrower. It also could go up or down. But this is the parent function, the foundation on which we will build. Let's take a look at graphing the parabola in vertex form. First of all, we need to be reminded of the equation of a parabola that is in vertex form. Vertex form is y equals a, x minus h, the quantity squared, plus k, where h and k represent the vertex. So please remember that when we have the h and the k, the minus is part of the formula. So the h almost appears to be the opposite sign of what you see written in the formula. For example, if this said x minus 2, the x-coordinate of the vertex would be a +2. If this happened to say x plus 5, In order to change the minus sign to a plus, the x-coordinate of the vertex would have to be a -5. A is the leading coefficient, and the leading coefficient again does several things. First of all, if it's positive, we know the parabola opens up. If it's negative, we know the parabola opens down. Secondly, it controlled the width. So we know that if the absolute value of A is greater than 1, in other words, the larger the number, bigger than 1, the parabola becomes narrower. As the number becomes smaller, or less than 1, meaning a fraction or decimal, the parabola becomes wider. So let's take a look at graphing a parabola in vertex form. The first step we would like to do is to find the vertex of the parabola. Please remember that the formula is y equals a x minus h, the quantity squared, plus k, where h and k represent the vertex. So our vertex, coming from our vertex form, is going to be at 1, 3. We know by the leading coefficient, and it is positive, that our parabola is going to open up. Since our parabola opens up, we know that the vertex is our minimum point. The next thing we would like to do is have our axis of symmetry. So let's graph the point 1, 3. Our axis of symmetry is what divides our parabola in half. It is a vertical line, and it is written as x equals, and the value of x that passes through the origin would be at x equals +1. Now what we're going to do is we are going to actually graph this using the parent function. In a previous course, you may have plugged in several different numbers, making a table, finding other points on the parabola, then finding those points of reflection and drawing your parabola. We're going to teach you today how to graph the parabola using the parent function. So we're going to start with x and our f of x, which is y. And we're going to remind ourselves what it would be if it were the parent function. Remember, the parent function is y equals x squared. So I can plug in several values. Let's plug in 0, 1, and 2 to begin with. So remember, if I plug them into the parent function, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So what we're going to do is create another column on our table that's called a f of x. In other words, I'm going to multiply the leading coefficient of this parabola, which is 2, times each of my y values, my f of x. 2 times 0 would be 0, 2 times 1 is 2, and 2 times 4 is 8. Now, here's how this works. What we are going to do is we are going to, from our new vertex, we are going to use this table. So 0, 0, that's where my new vertex is located. Even though I have shifted it to the right and up, we're going to call that our new origin, or our new vertex. Then I'm going to go to my next point, and the x says to go over 1 and up 2 for my vertex form. So over 1 and up 2, I'm going to put my new point. Then I'm going to go over 2 and up 8, which is the next one in my table. So over 2 from my vertex and up 8. 1, 2, 3, 4, 5, 6, 7. And it looks like I'm going to just be right above my graph. So then what we're going to do is simply to match the points on the other side of our line of symmetry. I went over 1 and up 2, so I'm going to go backwards 1 and up 2, or reflect the point on the other side of our axis of symmetry. I went to the right 2 and up 8, so I'm just going to go backwards to the left 2 and up 8, or simply go straight across the line of symmetry. Then I'm going to draw in my parabola. This method of using the parent function seems to be much quicker than making a table of values, having to pick our x's, substitute them into our equation, find the y value, and so forth. It will take a little getting used to, so let's do another one. Here's our next problem to try. First of all, let's find the vertex. The vertex is at the point -5, +2. Remember that the original formula is x minus h. In order for this to change to a plus sign, it needed to be a -5. Because there is a negative sign, which means -1, as our leading coefficient, that tells me that this parabola is going to open down. Since the parabola opens down, the vertex then is the highest point of the parabola, which means it is a maximum. Next, the axis of symmetry. What we will do, if it's easier for you to see, is we'll graph our vertex, which is at -5, +2. And notice then our axis of symmetry is the vertical line that must pass through the vertex. And so that is x equals -5. In other words, when we write our axis of symmetry, it is exactly the same as the x-coordinate of the vertex. We just need to write it in equation form. Now let's find the other points that we're going to graph. So we recall that the table that we started with for our parent function of 0, 1, and 2, remembering our parent function is y equals x squared, 0 squared is 0, 1 squared is 1, and 2 squared is 4. You might ask, is this what we use every single time? Absolutely. Now what we're going to do is create our third column, which is our a f of x, or multiplying our leading coefficient times our f of x. Our leading coefficient is -1. So 0 times -1 would be 0, 1 times -1 would be -1, and 4 times -1 would be -4. So from our vertex, which now becomes our origin, we are going to plot the points. So we already have our origin 0, 0. We consider our new vertex to be the origin 0, 0, as if we're moving our y and our x axis to cross at this point. Then we use our new values. The x value tells us we're going to go to the right 1, and our a of x, f of x tells us to go down 1. So right 1, down 1, and then we're going to go to the right 2 and down 4. From our origin, right 2, down 4. We can reflect those points to the other side of our axis of symmetry. And if we would like a better picture of what our parabola would look like, we can simply add another point into our table. So if x is 3, 3 squared is 9, and then we multiply a times f of x, which is our -1, times 9 would be -9. So from our vertex, we're going to go to the right 3 and down 9. And then we will reflect that point to the other side of our axis of symmetry and draw in our parabola. Some of you might be skeptical to say, does this really work? Well, let's just take a point that we already have on the graph. This point is at -4, +1. So if I plug in -4 in for x, -4 plus 5 is 1, 1 squared is 1, times -1 is -1, plus 2 is +1. So it works. Next, let's review standard form. The standard form of an equation is y equals ax squared plus bx plus c. So let's review how to find the vertex of our quadratic function. So remember, to find the vertex, we use the formula negative b over 2a, which gives us the x value of our coordinate of our vertex. Then to find the y value, we simply plug in the x value into our equation and solve for y. Let's practice graphing in standard form. The first thing we'd like to do then is to find our vertex. So the x-coordinate of the vertex we find by using the formula negative b over 2a. So we take a look, remembering that this is where the b is located, and it says I want the opposite of that number. So the opposite would be 8, and then I take 2 times the a value in my standard form, which is 2. So I have 8 over 4, which gives me an x value of 2. So for my vertex, I now know the x-coordinate, which is 2. Then I'm going to take the 2 and I'm going to plug it into the equation and solve for y, which gives me the y-coordinate of my vertex. 2 squared is 4. 4 times 2 is 8. Then I'm going to subtract 8 times 2, which is 16. And I'm going to add 3. 8 minus 16 is negative 8. Negative 8 plus 3 is negative 5. So my vertex is at the point 2, negative 5. Taking a look at my leading coefficient, which is a positive 2, tells me that my parabola opens up. Since my parabola opens up, I know that my vertex is a minimum. And my axis of symmetry, remember, passes through my vertex and has the same x value as the x-coordinate of my vertex. So x is going to equal 2. If I plot my vertex at positive 2, negative 5, I now want to have other points. We are going to use the same concept of parent function. And again, when we were graphing in standard form in a previous course, we would make a table selecting x values that were on either side of the vertex and then plugging them in and doing the mathematics and then graphing them. Here we're going to use the parent function. So if you recall, we plugged in the values 0, 1, and 2 to begin with. And since our parent function is y equals x squared, I plug in the 0, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I add my third column, which is a of f of x, and I'm going to multiply these by the leading coefficient of 2. 2 times 0 is 0, 2 times 1 is 2, and 2 times 4 is 8. So from my new location, my vertex now becomes my new origin. I am going to use those directions to find my new points. This is at my 0, 0, and then I'm going to use this part, which means go to the right 1 and up 2. I can reflect that point to the other side of my parabola. Then again, from my vertex, which becomes my new origin, I'm going to go to the right 2 and up 8. And then I'm going to reflect that to the other side of my axis of symmetry. Then I will draw in my parabola. Taking a look, my parabola does open up, which makes my vertex a minimum. The axis of symmetry is the vertical line where x equals 2. And another thing, if I take a look at my leading coefficient, it says that my parabola needs to be narrower, and it is. Let's take a look at another example. Y equals 1/2 x squared minus x minus 6. The first thing that we want to do is to find our vertex. So we use the formula x equals negative b over 2a. Remember that the b is the number that is in front of the x value, so we have negative 1, and we're going to divide that by 2 times our a value, which is the coefficient of our x squared, 2 times 1/2. So we have -1, 2 times 1/2 is 1, so the x-coordinate of my vertex is going to be at -1. To find the y-coordinate of my vertex, I'm going to take the -1 and substitute it into my equation and solve for y. So -1 squared is 1. 1 times 1/2 is 1/2, minus a -1, which would be +1, minus 6. So I have 1/2 plus 1, which is 1.5, and then I'm going to subtract 6, which gives me -4 and 1/2 as my vertex. Because my leading coefficient is positive, it's going to open up. Since it opens up, that means my vertex is my lowest point, so my vertex is going to be my minimum. And then I need my axis of symmetry. The axis of symmetry, again, is the line that divides our parabola in half. It is a vertical line, so is written x equals, and it is the same as the x value of my vertex. So we'll graph the point -1, -4.5. Now I could make a table of values, picking values on either side of that vertex, plugging those numbers in for x, solving for y, or I can use the parent function to graph. So remembering my parent function, I can pick the values 0, 1, and 2. 0 squared is 0, 1 squared is 1, 2 squared is 4. Now I will make my third column of my table. I'm multiplying a, my leading coefficient, times the f of x. My leading coefficient is 1/2. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. And 4 times 1/2 is 2. This is my vertex. This becomes my new origin. I now use the directions given to me in my table. So 0, 0, that's where my origin is located. Then I'm going to go to the right one and up a half a box. And then I will reflect that to the other side. Then I'm going to go to the right 2 units, 1, 2, and up 2 boxes, which is still halfway. And I'm going to reflect that to the other side. Then, because that doesn't have quite enough for my shape, I'm going to add my 3 in, remembering that 3 squared is 9. And when I multiply 9 times 1/2, that's going to be 4.5. So I'm going to go to the right 3 units, 1, 2, 3, and I'm going to go up 4.5 units. And then I'm going to reflect that to the other side. And you could continue if you would like to have more points to get a better shape, but this looks pretty good. So we'll draw in the parabola, and you'll notice since the leading coefficient is 1/2 that our parabola is a little bit wider. Let's review. We have vertex form, which is y equals a x minus h, the quantity squared, plus k. Our first job is to graph the vertex, and then we can use the parent function to graph the rest of our points. We also graphed using standard form, ax squared plus bx plus c equals 0 or equals y. To find the vertex, we use the formula x equals -b over 2a, and then plug that x value into our original equation to find the y value of the vertex, and then use the parent function to graph from there. Please remember to complete the reflection.